This is John Black, Super Chemist. This is just a disclaimer to let you know that this video is not intended to be imitated. No parts of it should not be copied or done by you or anybody. It's just for educational and maybe entertainment purposes to watch. That's it. I don't condone anyone repeating anything in the video. Hello, this is John Black, Super Chemist. We're here to make some diethyl ether. Up here, first of all, I chilled all my chemicals in the freezer. I got an ice bath here. And up here in the equalizing funnel, I have 90 milliliters of just train cleaner sulfuric acid. So whatever percentage is that, it'd be best to have 98%. In the bottom here, I have 100 milliliters of anhydrous ethanol, and like I said, I'm just going to drip that in there, and when they're done dripping, I'm going to let it heat up to room temperature. Okay, the 90 milliliters of ethanol, 100 milliliters or 90 milliliters of sulfuric acid, and the 100 milliliters of ethanol is in here. I put another 250 milliliters of ethanol here, although I wanted to put 300, but I thought that was a 500 milliliter addition funnel. It's not. It's 250, so that's what I'm putting in. I got a thermometer here. I want to make sure I don't get this past 145, but I want to get it up to at least 140. 145 would be good, better. And I got it'll travel up here through this Big Rick's column. It's basically just a distillation. I got a pot here so I can put some ice and ice water in there and make it nice and cold. Got a long condenser, and basically I'm just once this starts dripping, distilling, I can turn this on and keep the pot at the same ratio of alcohol to sulfuric acid. And that's pretty much it right now. Well, I got it under distillation. You can see over here. You can see the drip right now. There we go. Anyways, I got this at about 140 right now. It's still on over at 40 up here, although it was at 35 for a long time. I couldn't match my funnel, the sub funnel here. I couldn't match it, the drip rate to the over here where it's distilling. I'm right-handed and I put it on there, so I can't really get to it with my right hand, and it's fussy. You can't just turn it. You got to kind of hold it in there so it don't come out. So I'm just going to add a little bit in it, every once in a while. Basically, that's all I'm going to do until this is done. Alright, I stopped adding alcohol and the still head temperature up there. I went down to 35, and so I turned this on and I matched this drip rate. I don't know if you can see it dripping. So I matched that with the drip rate over here. And now I'm just going to wait. I'm going to keep this at 140 C pot, 40 C, and then I got a nice ice bath there. Nice cool condenser. Now I left 50 milliliters of ethanol in the sep funnel, so total I only used 200 in the sep funnel and 100 in the pot, which was 300 milliliters, plus the 90 milliliters of sulfuric acid. and it just stopped making ether, so I stopped it. This is a 500 milliliter flask, so I got about 250 milliliters there. So I put my product in a sip funnel. All my chemicals are cooled down. I got some saturated sodium carbonate, aqueous. I'm not going to measure anything out. I'm just going to top it off a little bit. Maybe top a little bit more. Shake it up. I'm going to do that twice with the carbonate. And then I also have saturated sodium chloride, aqueous. I'm going to, right after this, I'm going to do it with water. I'm going to do this twice, right? Wash it twice with this. Once with water and once with salt water. And always the bottom layer is the layer that you get rid of. You probably can't see the line, but it's actually like right here. Yeah, you can see it now. See it? Alright, so it's all washed. I actually only washed it once with the carbonate because it wasn't fizzing. I'm going to put some calcium chloride in here and anhydrous. Ah, screw it. No. I'm going to put this on a stir bar, stir it for about a half hour or something. Let it sit overnight, and then I'll distill it. Alright, so here we are with the distillation. I didn't even filter the stuff out, I just left it in there. You can see I have a Vigorix column on there. Ice bath for the receiver. I already started the distillation, I'm halfway done. So far everything's coming over between 34.5 and 33.5 centigrade, and that's what I think the boiling point is 34.5. So I'm hitting it good. You should always, if you're distilling anything, I mean, unless it's a, well, if you're distilling anything, you should use a Vigorix column. If the boiling point is under 60, you know what I mean, it can't hurt. You know what I'm saying? It only takes a second. And it doesn't take that much more heat for it to go up there. So I always, by rule of thumb, just always. I mean, I always, if it's 80 degrees or under, I'll use a Vigorix column. If it's above 80, I'm like, I don't know. Then it depends. But even if I don't need it, I usually put it on there. Just why not? Especially something like this, the boil's so low, it's ridiculously low. Gives you more control over the temperature, the steelhead temperature. Your control is so much better when you have that Vigorix column there. And you get better separation, you know what I mean? You never know. A little bit in there, now you got a little bit less in there, you know? Well, that's a 500 milliliter flask. It's almost half full. Say I got 200 milliliters, 225 milliliters. If I had 200 milliliters, it's about a 67% yield. If I have 225 milliliters, it's about an 84% yield. I'm going to put some molecular sieves in there and put it in the freezer. Does anyone know if you can put molecular sieves in the freezer? And if I put molecular sieves in there and then I put them in the freezer, is it going to collect a whole bunch of, like a bunch of water molecules in each sieve and then freeze and expand and break my sieves? Anyways, y'all have a great day, and always remember, science is great. I don't know if you can see that, but it's a thermometer. Adapter thing, you can unscrew this red part here. See, this is ground glass joints. You can put it right into a round bottom flask or anything really that has ground glass joints. But a lot of people, I don't think, know that You can use this not just for thermometer, but for a hose. You get the right size hose, it's nice and snug in there, right? So you can barely move it. Then when you put it in here, you can put it any length, so you can have it go all the way down to the bottom of the round bottom flask, or down at the bottom, whatever you're putting it onto. You know, you put it on anything. You can put it anything that has ground glass joint. But anyways, my point is when you put this on here and tighten it, it squeezes everything together. There's a gasket inside here, inside this red thing. I don't know if you can see. See that black? Oh, it's a gasket. See there? So everything compresses together, and you get an airtight pressure against plastic. You know what I mean? So that's a gasket in itself. And now you got to put up here. You can have it go down to the bottom, wherever, however length you want. You can adjust this. But anyways, just for gases or whatever.